Hey guys, just doing the answers to the practice test for this week, the measurement practice test. Just note that this is on mainly Pythagoras, area and total surface area. Okay, so I'll just be going through each of the questions. Just note I have my calculator beside me. Okay, so I'll be doing the calculations just to the side, but I'll be showing as much working as I can to try and explain things. All right, so for this, I'll try and do everything to 2 decimal points unless it says so otherwise. All right, so we'll get into it. Okay, question 1. Which of the following sets of 3 numbers could be the sides of a right-angled triangle? Okay, and then we've got A, B, and C with different lengths. Okay, so what I'm going to do first, I'm just going to draw a right-angled triangle as good as I can possibly do. Okay, and if we look at the 3 sets of numbers, guys, the biggest number is always going to be the hypotenuse, this longest length here. Okay, so this 10, the 9, and the 20 should all be the hypotenuse. Okay, but if we go back to our rules for Pythagoras, okay, we know that the length of a squared and b squared, if we add them together, will make the length of c squared. Okay, so what I'm going to do is I'm just going to write that rule up. Okay, so a squared equals, let me revert, a squared plus b squared. How do I go back a step? Yep, a squared plus b squared is going to equal c squared. Okay, so what I'm going to do for each of these questions, guys, I'm just going to use the first 2 values. So for A, 6 and 6, and see that will match up with the 10, okay? So if we think about it, for the first one, I'll get there. Our value of A is 6, and our value of B as well is 6. Okay, so what we've got, and our value of C is 10. Okay, so what we've got 6 squared plus 6 squared, and we want that to equal 10 squared. Okay, so if we do the calculation, 6 squared is 36, and 6 squared again is 36. Okay, and then 10 squared, 10 times 10 is 100. Okay, so if we do the next line of working, 36 plus 36 equals 72, which equals 100. So guys, we know that in this case, a squared plus b squared does not equal c squared. Okay, so A is wrong. Okay, so what we're going to do is we're going to keep going through our examples until we find the one that matches. Okay, so what we'll do is we'll do B, 7, 8, c squared is going to be, c value of the hypotenuse is going to be 9. Okay, so A, value of A is 7, plus 8 squared equals 9 squared. Okay, so 7 sevens are 49, and 8 eights are 64, and 9 nines are 81. Okay, remember guys, you can do this in your calculator, but 49 plus 64 will equal 103? No, 113. Trying to quickly do this in my head. And we can see, guys, that a squared plus b squared, again, does not equal c squared. Okay, so we know that a is wrong, b is wrong. We've just got to make sure that c is also right, or is going to be the right one. Okay, so we'll make sure. Okay, so our 2 smallest lengths are 12 and 16. Our hypotenuse is 20. Okay, so it's going to be 12 squared plus 16 squared equals 20 squared. Okay, so 12 squared, or 12 times 12 is 144. Plus, I'm just going to go to my calculator. Just got to remember what 16 squared equals. So give me 1 sec. Okay, 16 squared is 256. All right, and 20 times 20 is 400. Okay, so we're just going to make sure that this side equals this side, the left side equals the right side. Okay, so if I add 144 to the 256, which I'm doing in my calculator, okay, it makes 400. Okay, which in fact, a squared plus b squared will equal c squared. Okay, so the answer for the first one, I'll do it in blue, is C. Sweet. All right, moving on. So guys, if you do get caught or just need to go back, I think with the video, you should be able to go back, rewind, just to see what I've done. Okay, so question 2. What we've got to do is find the value of the pronumeral in this diagram. Okay, so it's a right-angled triangle. We're trying to find, let me zoom in a bit better. We're trying to find the hypotenuse, this value here. Okay, and we're going to apply our Pythagoras rule. Okay, so a squared plus b squared equals c squared. Doesn't matter if you write it the other way. C squared equals a squared plus b squared. It's still the same thing. Okay, so we know that our value of our a and b are 15 and... let me go back. Our value of a and b are 15 and 36. Doesn't matter which one you put in as your a and b. You still get the same answer. Okay, so I'm going to put the 15 as the a. 36 is the b, and it's going to equal c squared. Okay, I'll go to the calculator. 15 squared, or 15 times 15 makes 225. Plus 36 squared equals 1,296. Okay, and that's going to equal c squared. So I'm just going to add those, that left side together. So 225 plus 1296 equals 1521. All right, so that's the value of c squared, 1521. To get c by itself, guys, remember we've got to just square root both sides. Okay, so again, do that on your calculator. So the square root of 1521 is 39. Okay, just make sure on the question that if it asks in centimetres or metres or whatever it asks. Okay, but it doesn't look like it's asking for that. Okay, my a squared plus b squared wants to move along with me. I wonder if I can get that to stay. Please don't keep coming with me. I'll just have to try and leave it there. Why do you not want us? Okay, it's staying now. Cool. All right, B. Find the value of the pronumeral in this diagram. So in this case, guys, the 127 is our hypotenuse. It's our longer side. So it's going to be our value of C. All right, and we've been given one of the shorter sides. So with Pythagoras, guys, it's always a good habit just to write out the rule. Okay, and again, it doesn't matter if I put y in as my a or 45 in. You're going to get the right answer. I'm going to put 45 in as my a. We don't know what b is. All right, and we know that c is 127. Okay, so we're going to be dealing with some big numbers. Okay, so 45 squared is 2025 plus b squared equals, and then I'm going to square the 127, which is 16,129. Okay. What I've got to do now, remember this is going back to algebra, guys, or linear equations. To get this b by itself, what I've got to do is minus this 2025 from both sides. Okay. And that'll just leave us with b squared equals, and on my calculator, I'm just going to do this value here minus the value below it. So the 16,129 minus that 2,025. Okay. And I get that value as 14,104. Okay, just make sure, guys, that's the value of b squared. To find the actual value of b, we've got to square root this. Okay, and just to make sure you get the answer right, guys, it should be something that's, if we look at our triangle back on the left, okay, it should be something that's less than that 127, because that's our longest length. Okay, just visually, we can see that this y length is longer than the 45, so it should be in between 45 and 127. Okay, good way of making sure that you're doing it right. So what I'm going to do is just square root that value. Okay, and it does come to 2 decimal points. The value of b, I'll keep it in blue, because I've got 118 and 0.76. Okay, and I wasn't given any units, so I wasn't given centimeters or meters or anything, so that's our answer. Okay, question C. Find the value of the pronumeral in this shape. Okay, so what we've got here, guys, is we've got a trapezium. Okay. This question, what you've got to do is we're trying to find the value of this x here. Okay. What I can do is I'm actually going to see this triangle on the left of the trapezium. I'm going to redraw that. I'm going to draw that again over here. Okay. All right, so what we're trying to do is we're trying to find this value of x here, the height. All right. Remember, guys, when we've been given these little lines, they mean they're identical, so the same length. Okay, so this length over here is going to be 16. Okay, but we don't know what this length on the bottom is. But we can work it out using these two lengths on the bottom and top. Okay, so if the length up the top is 14, that means this length in between here and here on the bottom is also 14. Okay, but that leaves 26 left over. Okay, so we know the middle part's 14, the rest, the whole thing is 26. That means on either side, the left and the right, what I'm going to do is I'm going to take the 26 from the 14. Okay, and that makes 12. Okay, 26 take the 14 is 12. So that means either side, guys, I've got to fill that rest of the 12 in the left and the right. And because these two triangles, the one on the left and the one on the right, are the same length, that means this length here on the bottom is going to be 6. Okay, and this length is also going to be 6. Okay, so if I go back to my triangle that I'd drawn, without getting rid of my bottom. Okay, we know that this length now on the bottom is 6. Okay. All right, and what we're going to do is we're going to find the value of x, okay? Because it's a right-angled triangle, we can use Pythag again. So c squared equals a squared plus b squared. All right, our hypotenuse in this case is the 16, it's the longest length. So I'm going to fill that in for our value of c. Okay, again, it doesn't matter, the 6, if you want to put it in for the a or the b, you'll get the right answer. I'll just put it in for the a. Okay. So I'm going to do 16 squared. All right, which equals 256. All right, 6 squared, or 6 times 6 is 36, plus our b squared. Okay, now it's just our linear equation, solving for b. We're going to get b by itself, minus the 36 from both sides. So I've got 220 equals b squared. Okay, and then to get b by itself, make sure we square root both sides. Okay, so b is going to equal, and I'll just square root 220. Okay, and the value I've got is 14 point, and 2 decimal points, 0.83. Again, making sure our question wasn't in meters or centimeters or millimeters. It isn't. Okay, so we can just keep the answer as 14.83. All right, question 3. How long is the support wire on a flagpole that is anchored 1.5 meters from the base and reaches 3 meters up the flagpole? Okay, whenever you're reading like a worded question in measurement, guys, always, or you don't always, but it really helps if you draw a diagram that depicts the question. Okay, so what I've got is in this question a flagpole. So I'm going to just draw a flagpole, even put a little flag on it. All right, and it is anchored 1.5 meters from the base. Okay. It's anchored one. So this is where you gotta make is anchored 1.5 meters from the base and reaches 3 meters up the flagpole. Okay. So this is the support wire here. This is the flagpole on the left. I'll draw a flag. And this is the wire. Okay, what it says is that it wants to know how long the support wire is. Okay, so we don't know what that is. I'm going to leave that as X. Okay, we know that the wire is anchored 1.5 meters from the base. It should say from the base of the flag pole. Okay, so if this is the bottom of the flagpole here, it's anchored 1.5 meters from that. Okay, that also makes a right angled triangle. Okay, and the last bit of information we've been given there is that it reaches 3 meters up the flagpole. Okay, so where it attaches up the top here, okay, that's going to be 3 meters up the flagpole. So 3 meters. Okay, so with our picture, makes it easier to identify that this is a right angled triangle. We've got a base of 1.5 meters, we've got a height of 3 meters, and we've got to find what our length of our support wire is. Okay, and we can do that again using Pythagoras' theorem. C squared equals a squared plus b squared. Again, doesn't matter which way you write it around. Okay, so our C value is just X. Our A I'll put as 3. And our B I'll put as 1.5. Okay, so 3 squared. 3 times 3 is 9. Plus, again, guys, if I'm going too quick or you want to go back and look at something, just go back in the video. But 1.5 squared is 2.25. So what I'm going to do is add those together. 9 plus 2.25 makes 11.25. All right, and then to find the value of x, I've got to square root both sides. All right. Remember, it should be bigger than 3 because this will be our longest length. So square root of 11.25. Okay, I've got that as 3.35. And we did have meters as our unit. Cool. Oops, I realized I made a mistake here. This shouldn't say x squared. This should just say x. Oh, I'll just redraw it again. So x equals 3.35 meters. Okay, and if you wanted to add into that, you could say, therefore, the support wire is 3.35 meters long. Cool. All right, question 4. Use Pythagoras' theorem to find the lengths required. Okay, so we've got a rectangular prism there. All right, we've been given some lengths. We've got the 5 here, 7 and the 3, and right, we note that the units are centimeters. Okay, using the lengths AB and BC, find the length of AC. So when it's got 2 letters together, guys, it just means the length in between those 2 letters. Okay, so AB is, if I go from A to B, that's this 5 centimeters here. Okay, and using BC, that length here, what we're going to do is going to find the length from A to C. So I'll draw a green line across. Now, I always recommend, guys, if you can, draw another triangle just to depict that. So I'm going to use A and B as my base, A to B as my base. A, this is B. Okay, and that length was 5 centimeters. Okay, and then I'm going to use B to C as my height. Okay, and that length was 7 centimeters. Okay, and then the length from A to C is what we're trying to find. Okay, so definitely break the question down, draw separate triangles just to make it easier. Okay, you guys have probably got the hang of Pythagoras' theorem now. C squared equals A squared plus B squared. So our value of C we're just going to use is x squared equals 7 squared plus our 5 squared. Again, doesn't matter which one uses A and B. Okay, so 7 squared, or 7 times 7 is 49. 5 times 5 is 25. Okay, so 49 plus 25, 69, 74. Okay. And then to find the value of that x, or that length A to C, square it both sides. Okay, and write AC equals okay, 8.60. Okay, and then that length was in centimeters. Cool. All right, hence, find the length of A to G. So guys, if a question ever says hence, what it means is you'll pretty much be using the answer from the question before. Okay, so to find the length of A to G, we know that we will probably need this length of A to C. Okay, I'm going to go back up to our rectangular prism. Okay, what I'll do is I'll do it, the A to G is what we're trying to find. So I'm going to put that in red. Oh, that's not A to G. This is A to G, the top one. Okay, we've got our A to G there. And if you think about it, guys, you can sort of almost see a triangle inside that. I'm going to keep our red line going. But if we use this G to C, okay, and if I use that length we just had before, this A to C, you can almost see that there's a right-angled triangle in that. Okay, here's the right angle. Okay, and we can find those lengths. Now I'm just going to continue. I'll draw a separate triangle in a sec. But the length from G to C, okay, all these heights are going to be the same. So that's going to be the same as the length from E to A. So that height is 3 centimetres. Okay, and using our, because it said hence, here's our answer from before, this 8.6 centimetres. That's going to be this length down the bottom here. So that's that. I'll just write this as 8.6 here. Okay, it can get quite complicated if you want to do it all on there. I'm going to draw a separate triangle though. Okay. Oh, that's a terrible line. It's a bit better. Okay, so G to C. G was the length up, the vertice up here. This is C in the corner. And this was A on the left. Okay, so this length A to C we previously found was 8.6 centimetres. All right, and then we found the length of G to C, or we knew the length from G to C was 3 centimetres. Okay, and that'll help us find A to G. Okay, so again, we're using Pythagoras' theorem. C squared equals A squared plus B squared. Where our C is X, A uses 3, and 8.6 can be our B. Okay, 3 squared is 9, and 8.6 squared is 73.96. Okay, so guys, this is why we show working as well. It just makes it really step by step. Just ensures you don't make any silly mistakes. Okay, if I add those two values together, 82.96. Okay, because I definitely make mistakes. Let's hope I don't make one in this one. But by working, it just means you're doing less in your head, less in the calculator. All right, and you're just flowing on from what your working is. So that's sort of why I've been harping on making sure your working is really good. Okay, because then you're just following on from the previous step. I've got 9.108 in my calculator, so that 0.108, that 8's going to round that 0 up to a 1. Okay, and that'll be centimetres. Cool, which looks right because that was our hypotenuse. It's bigger than the 8.6, so that looks good. Cool, finally, a lot of Pythagoras. That's okay. We don't mind it. Again, once you get used to Pythagoras, it's fine. I've got a different question. Okay, I've got a circle, and I'm asked to find the perimeter. So guys, the perimeter of a circle is also known as the circumference. Okay, make sure you use the right rule, guys. Okay, so circumference equals 2 times pi times our radius. Okay, so our circumference is going to equal 2 times pi. And we've got a radius of 15 centimetres. Just be careful, guys, if they gave you diameter. Okay, if they did give you diameter, it was, imagine the diameter was actually 15. Your radius, you got to halve that. Okay, so just be careful. We were given the radius though, so that's fine. Just something to look out for. Okay, I'm just going to put this all in my calculator. So 2 times pi times 15. Which equals 94.2. So I've got 0.247. Okay, so that 7's going to round the 4 up to a 5. All right, and that's in centimetres. Cool. All right, next question. All right, perimeter of B. This is a good shape. All right, we've got some sort of area. Imagine it's your backyard. We're going to find the perimeter. Okay, we've been given a lot of values. But what we're going to do before we can find the perimeter, we've just got to know the value of this length on the side, on the left. Okay, and we've got to know the length of this one on the top. Okay, so it doesn't matter where you start. I might start with the length on the top. Okay, the length on the top, what that's going to be, that's going to be this 5 centimetres plus this 22 centimetres. That's going to give us the length all the way across the bottom. But then I've got to minus this 9. I keep saying centimetres, I mean metres. So I've got to add the 5 and the 22 and minus the 9. I'll just do that up here. Oh, not with that. With the pen. So 22 plus the 5 plus minus the 9. Okay. Which equals, so 22 plus 5 is 27. Again, you can do it in your calculator if you want. Then 27 minus the 9 is 18. Okay, so I'm just going to rub that out. Put that as 18. Up top. 18 metres. Rightio. Okay, so to find the length on the side, we're going to add the 5. Oh, not scribble it out. We're going to add it. Which is that one. Add the 5. Okay, we're going to add this other 5. Okay, and we're going to add the 10. And that'll get us the whole length on the side. So 5 plus 5 plus 10. Got a good number there. Will equal 20 metres. Cool. All right, now what we're going to do is just going to add up all of those lengths. Okay, so if you want, go out perimeter equals, and you can start wherever you want. 20, I'll just cross them off as I go just to make sure that's a terrible 8. Just to make sure I don't count something twice. Plus 9, plus 5, plus 22, plus 5, and plus another 5. Cool, all right, and I'll just put all that in my calculator. If you want to work your brain a bit, you can do it in your head. Okay, so I'm putting all this in my calculator, adding all those values, and the perimeter I have is 94 metres. Cool. All right. Moving on. Okay, so area. Question 6. Okay, so when you're finding area, guys, just make sure that you put the squared symbol at the end of your answer, just because we're dealing with areas in 2 dimensions, so the length and the width. So you need to have the squared symbol. Okay, so the area of a triangle, you can have these rules in your book ready to go. Okay, if you work with them enough, you'll remember them. So the area of a triangle is half times base times height. So the area equals 0.5, and our base is 15 times our 7. Okay, and you can put that in your calculator. Okay, so I've got 52.5 centimetres squared. Right, moving on to B. Okay, again, we're trying to find the area, guys. So just make sure you're writing the right rule. You're not using circumference this time. So the area of a circle is pi times the radius squared. Okay, we've been given the diameter. Okay, so we need to halve this 36 value. All right, so that radius is going to be 18. Okay, if you can't hear I'm at school, the bell's going. But we'll persevere. Area equals pi times, our radius is 18. Sorry if it's drowning me out. Squared, okay, and then just put that straight in your calculator. Okay, so the area I have for our circle is 1017.8, and if I round, it'll be 0.88 centimetres squared. Cool. All right, C. Cool, so you'll most likely get some composite shapes, guys, which are just shapes that are made up of a multiple of our normal shapes. Okay, so if I look at this, it looks like a bit like a teardrop or something. What I've got here, hey, how you going? I'm just doing a video. No, come in. I'll give this for you. And, you want me to check that out? Yeah. What I can do is I can pause. Okay, just getting back to the question. So what we've got here, guys, is, it looks like a teardrop, but if we break this shape up, what we can do is we can actually see some semicircles. Okay, so what I've got is I've got a semicircle across the top here. Okay, that can be semicircle 1. Okay, I've also got a big semicircle on the bottom. See how good my tracing skills are. Okay, that can be semicircle 2. Okay, and then I've got a little semicircle across from that. So that can be semicircles 3. Okay, so if we work out the area of this, guys, it's obviously going to be the area inside the teardrop. Okay, which that area inside the teardrop, all right, it's going to be 1 plus the area of 2, but then minus the area of 3. Okay, so I'll just write that there. I'll just write 1 plus 2 minus the area of 3. Okay, so what I'm going to do is I'm going to actually find the area for 1. So I might break this down. Area 1. Okay, I'll find area 2. Okay, and then we'll find area 3. Okay. So because it's all semicircles, guys, the area is going to be pi r squared, and we're going to divide that by 2 because it's a semicircle. So I'm writing this quite small. I'll zoom in a bit. So pi times radius squared. You can divide that by 2. So for the first semicircle, area is going to equal pi. Our radius, just be careful, we've been given the diameter, this 6, so we're going to halve that. Okay, so the radius is actually 3 squared on 2. Okay, if you do this on your calculator, all I'm going to do is pi times the 3 squared, press enter, and then whatever that answer is, then I'm going to divide it by 2, just to break it down into parts. Okay, make sure that it works out how we want it. Okay, so pi times 3 squared divided by 2. Okay, and in this answer, guys, I'm going to try and keep as many decimal points as possible, and that's because it's not our final answer. So by keeping as many decimal points as possible, it would just mean that when I'm working out the final answer, and by keeping all those decimals, we're going to get it pretty much as accurate as possible. Okay, so what I'm going to do, our area of that semicircle is 14 point, and I might write, if you write 5 or so decimals, I'd say 4 plus. All right, 5 decimals. It just means we're going to get it really accurate. Okay, so that's our semicircle of area 1. We're going to keep going with area 2. Again, because they're semicircles, we're using the same rule. Okay, if we go back to our... Now, this semicircle, the radius or the diameter we can see is the 6. I'll use a different colour. The 6 and the 4. Okay, so this radius is going to be half of, or 6 plus 4 is 10, half of that's 5. Okay, so we're going to have a radius of 5 squared on 2, which equals pi times 5 squared Okay, so the area I've got for that is 39.26990. Okay, all right, and then I'll find area 3. That's just that little blue semicircle. Okay. Notice I keep writing out the whole rule. It just so we don't make any mistakes. It's pi, and the radius of that, we see the diameter is 4 centimeters. The radius is going to be 2. So half of that 4. Okay, I'll do that with my calculator. Oh. On 2. Okay, my answer for that is 6.28318. Okay, what I'll do is I'll zoom out. Okay, so we've got our 3 areas. What I'm going to do now is I'm going to add area 1 and 2, all right, and minus area 3. Okay, so I'll keep them so I can see view, but also right. Okay, so area 1, if it'll let me, okay, is 14 point. I'm going to write it quite small because I've got to fit it all in. 716 plus, I'll give myself a bit more room, plus, that's terrible, plus area 2 is 39.26990, okay, and minus that 6.28318. Okay, I'll put all that in my calculator now. Might be a little weight. 0.116 plus 39.26990 minus 6.28318. Okay, so the final answer to 2 decimal places is 47.3 12 centimeters squared. Cool. All right, so what I might do is I'll start putting our answers just in boxes, just so when I send out these answers, you guys can clearly see what the answers are. So I'll quickly do that. But just one thing, guys, to note with this stuff, we're not really getting any harder. The questions are just bigger, and there's just a couple more steps to them. We're still applying our area rules or our Pythagoras rules. We might just be adding... Oh, that one's not that one. We might just be adding, a couple more steps. But I think that's something I like about measurement is... you start to build up pretty quickly to some thought-provoking questions, which is good. Okay, and I've already got the C for that one. Cool. All right, so I've just done that so when you can see it when I send it out. Rightio, question 7, total surface area. Okay, so total surface area, guys, remember for a rectangular prism, it's going to have 3 pairs of faces that are exactly the same. Okay, so one face I'm going to have is this 10 and the 6, because the height's 6. So I'll draw a little rectangle. 10 times the 6. Okay, and because I've got 2 of those, remember to find the area of a rectangle. I'll get into the working after. It's length times width, but that's going to be times 2. Okay, the next face I've got, this one on the side I'll do here. So it's got a base of 2 and a height of 6. That's not going to work. Should look more like that. 2 and 6. Again, we have 2 of those, so times by 2. Okay, and then the last face I have is this one it's either on the top or the bottom, however you look at it. Okay, which is 10 by 2. I don't think green will agree with a few people. 10 by 2. Okay, so we're going to add those areas all together to work it out, the total surface area. So write it over here. TSA is going to equal. Okay, and all I'm going to do is I'm going to just whack all this into a calculator, into our equation, just adding them all up. So it's going to be 10 times 6 times 2 plus 6 times 2 times 2 plus, all right, and this one's also got 2 of those, so it's going to be 10 times 2 times 2 equals. So in your calculator, guys, I suggest doing the brackets. Or if you want, you can work them out one at a time and then add them together. I'm going to actually, in my calculator, I'm going to do it all in one. So I'm going to include the brackets and then the plus in between the brackets, do it all at once. But if you want to do it individually, if you do it without the brackets, you may not get the right answer because of BODMAS. It may add the 2 and the 6 and it just gets muddled. So do them in the brackets or do them individually. So just remember, guys, total surface area is that total area on the outside of the shape. Okay, you're adding up all the area of the faces. Cool, so the total surface area, I've added all those together. I've got as 184 centimeters, and because it's area squared. Cool. All right, on to the next one. All right, I might draw a line just to separate those. Okay, we have a cylinder. All right, if you watched the PowerPoint last week, it sort of went over the origin of the rule for a cylinder. But essentially, we're adding the two areas of the circles. Okay, so the area of a circle is pi r squared. Okay, and because we've got two of them, it makes it 2 times pi times r squared. Okay, then we've got to add the rectangular part. Okay, which is actually the height times the circumference of the circle. All right, the circumference of the circle. And we've done a rule on circumference, okay, which is 2 times pi times r. Okay, so that's our rule. So our total surface area is 2 times pi times our radius we've been given is 8. Okay, the height of our cylinder we've been given as 12 times 2 times pi times 8 again. Okay, again, guys, you can do this in parts. You can do this part and add them together. Or you can add the brackets, just so your calculator doesn't make a mistake. Because it doesn't, the green calculators don't factor in bod mass. So the brackets, or doing in parts, is important. Times 2 times pi times 8. Rightio, so the total surface area I've got for that is 1,005.31 centimeters squared. Cool. How are we going? Is that it? Cool. That's it. All right, so this practice test, guys, just going over it briefly. There was a lot of Pythagoras sort of stuff at the start. Okay, and then question 4, we're sort of dealing with 3D Pythagoras. Question 3, we had a worded response, so drawing out pictures, guys, when you get worded questions. Okay, question 5, we're dealing with circumference and perimeter. Question 6, we get into some area. Oh, I just noticed I didn't do D. So I'll do that now. Okay, and the last one, 7, was some total surface area. So I'll quickly go back and do D. I'll zoom in. Didn't mean to miss that one. Oop. Okay, so what we've got here, guys, is we've got to find the shaded area. It doesn't actually say that in the question, but what it'll want is the shaded area. Okay, so the shaded area is the part inside the circle. Inside, I really shouldn't be drawing there. It's bad. Inside the circle, but outside the, what is it, the square we've got here. Yep. Okay, I really like this question that it actually hasn't given you the lengths of these, the square here. What we can do though is we can find that. How can we find that? I know a way, but there's got to be an easier way. All right, we're going to look at the square. Okay, if we just look at the square, guys, I'm going to draw a triangle from the square, so half of that square. Okay, we know the diameter was 10. Okay, and these lengths are the same. Okay, because these lengths are the same, what we could say that this is A, All right, and this is also A because they're the exact same. Okay, so if we apply Pythagoras' theorem, we know that C squared equals A squared plus B squared. There might be an easier way than this. This is just what came to mind. Remember, it doesn't matter how you get the answer as long as you get it. So C squared is our hypotenuse, is 10. Okay, and what we're going to do is I'm going to sub in just our lengths of A for each. Okay, so it's going to be A squared plus, okay, trying to get confused, our value of B is also A squared. Okay, so if we do 10 squared, that's going to equal 100. Okay, and this is going back to our indices, guys. I've got like terms here. I've got an A squared and an A squared. Okay, so in total, I have actually 2 A squareds. Okay, and what I can do now is I can solve for A. So I'm going to divide both sides first. We're going to get A by itself. Okay, so it's going to be A squared equals 100 divided by 2 is 50. Okay, and then to find the value of A, I'm going to square it both sides. A equals square root of 50 equals 7.07. Okay, I may even keep a couple of decimals just so we're really accurate because it's not going to be our final answer. Okay, so the whole point of doing that, guys, we know that this length because it's a square, it's going to be the same, is 7.07106. Okay, we need that length to find the area of the square. I'm just going to continue this on. The area of a square, guys, is the length times the width, or length squared. So it's actually going to be this 7.07106 squared, okay, which equals 7.07106 squared. So I'm finding the area of the square, guys, here. Okay, which pretty much gets us back to 50 because we did that question before. So it gets us back to 50 centimeters squared. Okay, now we're going to find the area of the circles. All right, square here. Square area. I think this is probably the toughest question in the test. All right, circle area. Oh. Okay, that's going to equal, we know the circle has a diameter of 10. Okay, so its radius is going to be 5. Okay, so that's going to equal pi times 5 squared, which equals, my working's getting a little bit cramped. Pi times 5 squared. Okay, that equals 78.5398. Just note I haven't gone to 2 decimal points because it's not our final answer yet. Okay, so what I'm going to do, guys, if we look back at our shape, we want to find just the shaded parts in here. Okay, so that's going to be the area of the circle minus the area of the square. Okay, if I do 78.5398 minus the 50, oh, it's getting real cramped. How do I get that U to stay? I'll go over here. So 78.5398 minus the 50. Not in red. 78, so the area of the circle minus the area of the square, okay, is going to equal 28.54 centimeters squared. Okay, I'll put that in blue. Righto. So I think that's the answer to all our questions. I'll just box this one off. Okay. Up. Please don't move with it. Go back. Righto, guys. If there's something you still don't understand about the test, let me know how I did it, or if you did it another way, guys, it doesn't matter. As long as you've got the right answer. You might have done something different to me, that's fine. Hope that helped. Okay, I'll speak to you soon.